Hi, my name is Bob from Kanai Media. Today we're going to talk about the word access modifier in C#. Hi, my name is Bob from Kanai Media. Today we're going to talk about what access modifiers in C# are and what they're being used for. In C#, access modifiers are keywords that determine the scope of accessibility of classes and their members. A class member includes the field, the property, and the method. There are 6 access modifiers in C#. We have the private modifier, the internal modifier, the protected modifier, the protected internal modifier, the public, and the private protected modifier. Now let's look at each of them in their own right. At the class level, the access modifier is written before the declaration of the class. Okay. If no access modifier is specified, C# renders the class as its internal. Okay. So internal is the default state of the class declaration in C#. A class can either be public or internal and nothing else. What that means is you cannot declare a class in C# with the private keyword as access modifier, nor can you declare a class in C# with a protected internal nor protected private protected. You can only declare classes in C# as internal or public. We're going to see the implementation of those later on. So you see, like the example over here, public class person, or the name of the class, your class, or you can declare it as internal class plant, or the name of your class, or just as the default declaration that is rendered by C#. And when this class is declared without the keyword, C# will render it as internal. The class would behave as internal class. So when we go through the access modifier, then you will see the scope of each access modifier. Then we'll begin to understand how to design our software, our program to better get to this the objective. All 6 access modifiers are applicable to the member levels. If no access modifier is specified, C# renders the member private. So we see a staunch difference between the default state of private members, which is private, and the default state of class specification, which is internal. If no keyword is used for the class to specify the access for the class, C# renders the class internal. If it is not given a specification for modification, access modification is not specified at the member level, C# renders that member private. Okay, I think better we should write default here. Okay, as default. Let's write default. Okay, for better understanding. Okay, and here. Okay, now a private access modifier gives access to members of the class in which it is declared. Outside the class in which the private member is declared, no accessibility is given. Okay, now the internal property, the internal access modifier exhibits the private property, which is it gives access to the members of the class in which it is declared. Then it extends access to any other class but of the same assembly. Alright, now we go to protected access modifier. It exhibits the private property, which is giving access to members of the class in which it is declared, and on top of that it extends access to members of derived classes from anywhere. Protected internal exhibits the private property and extends access to any other class of the same assembly, which is the internal property. So it exhibits the private property. This is the internal property. We see the internal here. The internal property extends access to any other class of the same assembly. We see it here. So protected internal, private property exhibited, internal property is exhibited. That's why it is protected internal. Extends access to any other class of the same assembly, any other class of the same assembly, and also extends access to members of derived classes from anywhere. So exhibiting the protected property. So protected internal exhibits private property. It exhibits internal property. Exhibits internal property. Internal property. Here it exhibits no, I shouldn't do that. Doesn't make sense. Okay, stay like that. We understand. We can understand. Extends the access to members of derived classes from anywhere. Now public, of course, public has no limitation, no restrictions at all. The public declaration, every member of the public, being the class or the member, is accessible from anywhere. Now the private protected is a new feature in C# 7.2. The private protected exhibits the private property and extends access to members of derived classes of the same assembly. Members of derived classes of the same assembly. This is a special one. Not the difference here is different. This one, private protected, extends access to members of derived classes of the same assembly. So it's different from protected internal that extends access to members of derived classes from anywhere. But this one is from derived classes of the same assembly. Alright, let's dive into Visual Studio and see how we can implement these scopes, okay, and verify how far these access modifiers can allow access. Now let's go and create a project, a console application. File new project. Let's have console application checked. Let's name our application. Let's call it access modifiers, and let's give a little slight different name for the solution, access modifier solution, just to make sure we don't get confused which one is the solution and which one is the project. So access modifiers for the project and access modifier SLN for the solution, just to keep it different. Okay, all right, hit OK. Building our solution. Okay, okay, it's winding up. All right, so we have our solution. This is our solution. This is our project, and this is our solution. Okay, now, and the solution, C# has given us an entry point into our program. Okay, the main method. All right, so we need a class. We need to add a class where we can list the access modifiers that we want to measure the scope of. Okay, we add a class, and we can call this class, we can name this class, we can call this class master class. You can call it any way you want. I just want to call this one master class. Okay. Alright, now in our master class, what do we want to measure the scope of? We want to measure the scope of the private property. Private, let's say, let's give the two common opposite ones that we use all the time. Excuse me. We have number 5. Okay, this the public. Okay. Okay, in between these two, we want to measure the scope of internal and protected. All right, and protected internal. These are the fifth one. These are the 5 access modifiers that Microsoft had declared before C# version 7.2. From the onset of C# 7.2, Microsoft incorporated the 6th one, that is called the private protected. Alright, so we have the 6 access modifiers. So we can just create a method where we can verify this and confirm that it is actually being seen somewhere else. So we can create, let's say we create a private method, create a method, a void method, which we don't expect any return. Private member, let's call this private member, and we can just console log, console write on the console. We can write on the console, right line, so the right line, I am a private member. Alright, that makes sense. Alright, okay, so let's see. Let me also make mention of this class declaration without access modifier. As we said before, when at the class level, when a class is declared without an access modifier, C# renders this class as internal. Alright, so we expect to have expect to have this class behaving as an internal. Alright, and what is internal? An internal class. A class is described as internal. Internal class. An internal class is a class which is seen only, whose scope is within the outer environment. An external class, we did not make this one. So at the class level, the access modifier. So when an internal class,
is that whose scope is its outer environment.
Same application, same definition for these. It means the same thing. And the outer environment of a class is its assembly. So if a class is declared as internal, this class cannot be seen from outside that assembly. Any other class from outside that assembly cannot see the class. Only classes that are within that same assembly are able to see this class. Okay, so let's see now. This class is declared as internal. Now let's see, let's go to private to program.ts and call this class and call the master class. Okay, so because see what we'll do, because we're gonna create an external project where we can verify the scope of this class and its member from the outside of this assembly. So let's create another project. We have this project and this program. Let's say let's rename this program. Let's rename it as internal program. Internal meaning that making reference to the fact that it is in the same assembly as the master class where we have our access specifier. So let's say internal program. Okay, yeah, internal program. Yeah, let's want to change that. Yeah, we do the changes. Now I want us to add another project in this solution. Let's add new project. Okay, let's call this one access modifiers 2 in the same solution. Okay, access modifiers 2. Now access modifiers 2 has its own entry program, an entry method, the main program. So to be more relevant, let's call this our first project, access modifiers, and this is our second project, access modifiers 2. So this is one assembly, this is second assembly. So let's call the program, the entry point of this project. Let's rename it to external program. External being referring to the fact that it is not in the same assembly as the master class. Okay, I hope that is understood. Okay, now let's call the private. Let's go back to the first assembly, access modifiers 1, and in the entry point let's try to call the master class. So we have an instantiation of the master class. So we go master class MC equals to new master class. Okay, now let's see the scope. MC dot, we can't see anything. There's no private. We can't see the private. No, we can't. Why? Because private, where is it? Yeah, private gives access to members of the class in which it is declared. Right? Gives access to the members of the class in which it is declared. So any private property, any private member can only be seen by members of the same class in which it is found. So internal program is a class, even though it's in the same assembly. Internal program is in the same assembly as master class. Private can only be seen within the members of this class. Alright, that's it. We cannot see any private outside of this class. Now that is understood. Now let's go to try to call this master class outside of the assembly. We can see this master class, which is declared as internal, default is internal. We can see it, like we can add internal here, just here, internal. Okay, internal class behaves the same like the default, same thing. It is seen in in an internal program, it stays in there, so we can have no errors. We can build. Control Shift B, it builds. Okay, it builds. It builds. Okay, build successfully. So let's go. So default state and internal behave the same at the class level. Alright, let's go to the external program, which is not in the same assembly. Let's try to call the master class. So we go master class. Now, so first of all, we have to make reference to this master class because this is a different assembly. So we have to make reference to it. So right click reference, add reference, access modifiers. So the access modifier is found in this project, so we make reference to this namespace, this project access modifier. Okay, so see, okay, so there we go. So access modifier has been added to the reference of access modifiers too. So we go master class MC is equal to new master class. Wiggly error, nothing. Wiggly error, nothing. So it's not being seen. The reason being that master class is declared as internal. Master class is declared as internal. So what is internal? Internal has private property. This extends access to any other class of the same assembly. But you see that external program 2 is not in the same assembly as the master class. Master class assembly is access modifiers, while the external program 2's assembly is access modifiers 2. So they are in different assemblies. So while master class can be called within this assembly by any class, it cannot be called within the assembly of another class. So if we change, let's say, let's go here, master class, let's change it, let's leave it as default to show that it behaves the same as external. Let's save. Alright, we still have our wiggly external program, we still have our error to show that it is not still being seen. But if we change it to public, let's say public, remember a class can be only be declared as public or internal. Now if we change it as to public, now the wiggly goes away, can be seen. Okay, now it will be able to be seen. Alright, well, we have to build, since we've changed the property of the class, we have to build it for it to take effect. So Control Shift B, have to build it. Okay, it says error. Let's see what error. Yeah, we hold this one first so that it can build. So then we'll build this project. Build. Okay, build successful. So build successful. Then we'll take this one off. Then you go and build again. Oh no. Okay, then okay, we namespace, bring in the namespace. Okay, namespace, import namespace. Okay, so then we build and everything is fine. Alright, So if when the master class is declared as public, it can now be seen by any class anywhere, so that's why it can be seen at the external assembly, okay, the other assembly. Now, but the thing is, we cannot still see the private property. So when we go mc dot, nothing, there's nothing. Look at the intelligence here, nothing. There's no member that can be accessed. So we cannot access the property, the private property of any class, the private member of any class from outside the same class. Now let's see if we can successfully access this method within the same class. Let's create a public method. Let's create a public method. Let's say let's say public void get private members, okay. Let's say console dot right line, console dot right line, I am a private member. Console no, we just call the method in here. Sorry, we just call the private method in here. See if you can see it. So what's the name of the method there? This is the name of the method. Copy and paste. Now I just copy the method, copy and paste. Okay, copy and paste. Yeah, it works. Can be seen. No wiggling. So now let's see. So let's see if we can call it now in the internal program. So master mc dot, now we see get private method. Okay, when we run that, we expect to see console right line, I am a private method being called in the public exposure of this private property. So we expect to see written on the console, I am a private member. Yeah, so at least it can be seen in here, right? So let's run it and see. Now let's hold the window so that we will be able to read what is written on the console dot read line. Okay, alright, now let's run this program. We expect to see I am a private member. That's what we expect to see on the console. Hi, I am a private member. So it works. So we cannot see the private member as outside of a class. We cannot see an intent and we cannot see an internal class outside of the assembly, but we can call a private member only within methods within the same class in which the private member is declared. So we've understood that. Now let's see if we can go to external external programs, and we can still call mc dot. We cannot have private member, but we can get private get private member. Yeah, we can run it from here as well, and we say console read line as well. Consider real. Yeah. Now let's make sure we know console dot right line assembly 2, so that if we don't see this, we know it's coming from assembly 1. So now we want to run the second project. Okay, we want to run the second project, so we have to click on the solution. We have 2 projects in the solution, more than 1 project in the solution. We want to set up how the programs are run, the different programs in the solution. So go to setting, build a project, build order. Okay, here it says, okay, this is that's not what we want. Solution, set startup project. Okay, set startup project. Yeah. Sure. Okay. Single startup project. Now current selection, the one which is selected should run. So this is how we set up the startup project. Okay, the one which is selected is the one that has to run. Okay, so we say okay, so here if I select this one, then I run this program, solution, the assembly 1 will run. Okay, I am a private member. Now when I select the second one, when I select the second project and I run, we have to say assembly 2, then blah 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 blah. Assembly 2, I am a private member. So this is exactly what we're talking about. So now we have seen the scope of internal and private. Yeah, so now let's go steps further and declare internal members. Okay, so console dot right line. Oh, what we're doing, we need to declare a method here. So I say internal void expecting no return, internal member. Right, there we go. Console dot right line, right line, right line, I am an internal member. Okay, yeah, like so. And in protected we say protected void expecting no return, protected member. Console, just copy this. Very painful to type all the time. Yeah? And just change it. I am a protected member. I am a protected member. So I can copy this and paste here. Paste here. I will say protected internal void. The internal void. I am a protected internal member. The internal void. Now copy and paste here. Private, not public. Public. Public member. I am a public member. And the last one, protected private, private, protected void, private, protected, protected member. I am a private protected member. Okay. Private protected void. Now it's giving out. The reason it's giving out is because my C# here it's 7.2. It's 7.0, and this sith access modifier only came into effect from C# 7.2. So I have to upgrade my C# version to the latest, or version 7.2. So I'll just choose go for latest, and the error goes away. Okay, there you go. So now let's see the scope of each. We've seen the scope of private. Now let's try to see if we can see the scope of the internal member in the internal program. So we'll say MC dot. There we go. We see the internal member. We see the internal member. MC dot. We see the, forgot about the get private, we did that already. We see the protected internal member. This is being seen through this object because of the internal property, not because of the protected property. Okay, you should not take note of that. So yeah, then we're going in MC dot. We have internal member, we have internal protected internal member, and of course we have the public, seen by anyone, anywhere. Okay, so these are the ones that can be seen from within amongst the 6. These are the ones that can be seen from within the internal program, that is within a class which is in the same assembly as a master class. That is a class in which the properties are being, the members of the class are being declared. So now let's go out to the external program and see if we can be able to call to access these members. So we'll do the same MC dot. We can get only to the private member exposure or the public. That's it. Or the public member. Why is that? Let's see, master class is public, and we can access this one in the same assembly, any class in the same assembly. That's internal member. Any class in the same assembly. Internal, yeah. External, any class of the same assembly. And then we didn't access this one. Yeah, let's see. Protected internal member. Yeah. So protected internal. Yeah, we got protected internal member. Why? Protected internal member. Protected internal member because it is access extends to any other class of the same assembly, because it's exhibiting the internal property. The internal property, this one, okay? They exhibit this property. It has dual properties, dual behaviors. It behaves like protected, at the same time it behaves like internal. So we are able to see it there. Okay, now let's go to public, and the public, which is accessible anywhere. So but here we're able to see just public. So MC dot none any, no any. Yeah, you can see there's no class that can be seen anywhere by any class except the public. So we can only access the public property. That's it. There we have understood the scope there. Alright. Any other external program, because most of the properties have external internal properties, most internal behavior, sorry. Most of the members have internal behavior except public, which is in anywhere. Alright. It's in anywhere. Yeah. Public, which is in anywhere. Okay, this one, which is in anywhere, must be derived. Okay, so we have to understand that. So that's the scope of the the scope of accessibility of these members. Now let's try to create a class first internally that extends master class. Then we'll create another class externally that extends the master class, and see how we can access these members of the master class. Okay, so from there, an external class that extends master class, an internal class that extends master class, then we'll see how these members can be accessed. Alright, now let's go to internal. Let's go to the project 1, access modifier, create a new class, add a new class. Okay, the same assembly, so we try to call it internal child, yeah? Child demo. Yeah, so how do we call the other ones? External program. Okay, yeah, so that was the external program, internal program. Now we call this internal child demo. Okay, internal child demo in the same assembly as a master class. So we have to say this class extends the master class. Extends the master class. So we create a method that will call the members of the master class, or that would inherit the properties of the master class. So we go public void expand return internal child test. Okay, method. Okay, internal child test. So we see what properties can we inherit from there. Let's see if what can be inherited from instantiation. I know we can inherit property, the public property. So master class MC is equals to new master class. dot, what can we access? Forget this one. This where we expose the private properties. We can from the objects we can access internal member because it's exhibiting the internal property. Okay. MC dot protected internal member. It has dual behavior. It behaves as a protected member and it also behaves as the internal member. Since we've been able to access this property, this member, through the objects of this class, the behavior that is permitting us to see through this object is the internal behavior. That's why we can see that. Okay, is the internal behavior of its dual behaviors, or the internal section of its dual behavior. Okay, MC dot, what else? Of course the public. Okay, of course the public member, which is in anywhere, anytime. Okay, so now let's go to direct inheritance, see what we can see. Can we go for private? Let's start with private. See, let's forget about this one. As we mentioned before, we can inherit private protected. Here we go, because internal child class is in the same assembly. Internal child class is the same as the child demo is in the same assembly as the master class, and the external child demo is inheriting from master class in the same assembly. So it is now able to see this private protected extends access to members of derived classes or child classes of the same assembly. That's why it has been able to see this. This is the only instance or only occasion where the private protected member can be seen or is exposed. This is the only occasion. Right? There you go. There you go. Now what else? Private protected? No, we can get protected internal. Okay, remember the protected internal over there. So we can access protected internal in two ways: through the instance because of its external internal behavior, and through direct inheritance because of its protected behavior. Okay, so what else can we inherit? Private. No, those are the two. Let's select protected. Nothing, still the very two. Of course, we get the protected member now. We get the protected because of its inheritance behavior. Okay, so this is how we can access these two instances of the class, and we can access these ones directly. See, this one can be accessed in two forms because of its dual behavior. Okay, so we get that. Now let's go to the external program demo. Right, let's bring this one here. Yeah, let's keep that there. Master class here. Okay, let's go to external demo, see what we can do there. External demo, no, not external demo, sorry. What was I trying to say? Okay, internal child demo. Alright, is this, yeah. Okay, now let's create another class in the external, in the other project. Let's create a child class in the other project. Add class. We'll call this one, we call the other one internal child demo. We'll call this one external child demo. External child demo. Okay, okay. Now we do the same. Let's go there and just copy. Okay, saves us some time. We just copy this and then edit. Okay. Alright, so we're gonna just change this to external child test, external instead of internal. External child test to indicate that is the external class. So master, we have to import namespace. Okay, there you go. So we can access this. Now I will get rid of all this. Do it one. Okay, now MC dot, we can get only the public member. Of course we know why. Only the public member is accessible at this stage by the, now did we inherit? No, we did not. So come on, no, we have to inherit master class, inherit from master class. Okay, so which means what, apart from that, from public, what can we get? MC dot public member. Okay, just public member. We already dealt with this, so forget about that one. Can as well take that one out so that it doesn't keep coming up and confusing us. Okay, so what is it? Master class get. Okay, so we can just comment that one out. Okay. Okay. Alright. So say MC dot get only the public. Okay. Nothing else. So cannot get any other thing there. Now let's see through inheritance, direct inheritance, what we can get. Through direct internal, let's try private. We can get protected internal. Okay, protected and internal. So we are able to see this outside the assembly because of its protected behavior, not internal behavior. Okay, what else can we get through direct inheritance? Protected member, of course. Okay, those are the two we can get from there. So these are the scope. These are the scope we can get. Protected internal because we're able to see these outside. Protected internal because it has dual behavior. It behaves as a protected member and as an internal member. We're able to see it outside of the assembly where it is defined, it is declared because of its protected property. And of course we can directly inherit the protected member because this is a child class. We can directly inherit the internal member. We can also directly inherit the public member. Yeah, so we can directly inherit 5 out of the 6. The only one we were not able to inherit directly is the private member. Private member cannot be inherited. You cannot see the private member except in the class in which it is declared. So that is a no-no. Okay. Now, so internal demo. Okay. So we're able to inherit 5 of the 6. Okay. Alright, let's try it. I want to call this an internal demo. Why is it giving out here? Okay, we took it away, so you go out. Don't need you. Take the method out. Okay. And here. Yeah, method is gone. Let's call this this class in the internal program and see how it behaves. Okay. New internal child demo. Internal child test. Okay. Run. This is the first project. Okay. Make sure it is selected the first one. Here you go. These are the direct inheritance, the 5 properties inherited. I am internal. Okay, we can understand everything which is happening here, and so on. Okay, so everything works. Now let's test the second project. So we do the same here. External program, CS. External charm. External. Demo.external test was the result of project 7 project and run. Assembly 2, I am a public, okay. Project internal member, I'm a project member. What does that say with? So I believe this tutorial was able to demonstrate to us how we can access the different we are able to measure the scope of the different access modifiers. Alright, so if you like my video, please give a thumbs up. And I know it's not been perfect, the audio is not good, but I'll definitely make some changes and make them better in the future. If there's something you need me to explain that I didn't explain well, that you want to have more insight on relating to what we just studied, please leave me a comment and I'll definitely try to get to you.